Alrighty. So this is less than ideal. I'm going to actually skip some of these. There's so many notes, and I don't necessarily want to go through all of them. They are all online, all on Schoology, filled in. So I kind of want to talk about the gist of what you need to know. And what we're talking about today and need to know today is end behavior, which means exactly that. What are the ends of a graph doing? And you want to get to the place where you can just know what the ends are doing by looking at your function and the numbers, like the degree and the leading coefficient, the things that we talked about yesterday. So I'm going to find a little spot to work here. Let's cut to the chase. When you look at a polynomial, the thing that you're going to do to determine end behavior, meaning, again, what are the ends doing? We're going to talk about it first in simple terms and then write it in kind of fancy terms. So end behavior is going to talk about left end, right end. So think about what this looks like on a graph. You guys know that this is the right end and you know that this is the left end. So keep in mind that this is the x-axis and that this goes towards positive infinity, this goes towards negative infinity. I am pretty sure you know this is up and this is down. You also know that this is the y-axis, and probably you can figure out that this is positive infinity and negative infinity because we've talked about it a million jillion times, which is a lot. So what we're going to be looking at is deciding, is the right end going up or down? Is the left end going up or down? And we're going to write it in fancy math language because we're fancy like that. So when you have a polynomial, you're going to have your leading coefficient, you're going to have the x, and then you're going to have the degree. So here's what we're going to be taking a look at. This is your degree. If this degree is even, that tells you you're going to have what we call the same ends. This is like Reader's Digest version of what you need to know today. Meaning both the right end and the left end go up, or they both go down. They do samesies. They do the same thing. If you had to take a wild guess, what happens if that degree is odd? Well, if your degree is odd, you're going to have opposite ends. So thankfully, alliteration is real, and you have odd goes with opposite, so that'll make it easier for you to remember. So if you have an odd degree and the right end goes up, the left end of your graph is going to go down because they do the opposite. Or maybe the right end goes down, then the left end will go up. So this is genuinely just memorizing. Like, what if this degree is even? Then they'll do the same thing. What if this degree is odd? Then they'll do opposite of one another. Okay, but then we need to know which direction they're going. So we look at the second piece, which is out in front, that leading coefficient. If that leading coefficient is positive, the right end will go up in the positive direction. If your leading coefficient is negative, then the right end will go downward, which is negative. Now notice it doesn't tell you what the left end is doing. So we need sort of the combo platter. We're going to look at that leading coefficient to find out what the right end is doing. It's either going up or down. Then we're going to look at the degree to see, okay, are they doing the same things? So then if the right end's going down, the left will also. If the right end's going up, the left will follow. If you look at the degree and it's odd, then you know they're doing the opposite. So if you know your right end's going up from your leading coefficient, then you know that the left end's going to do the opposite. And then same thing over here. If you've decided that your leading coefficient's negative, so the right end is going down, and you have an odd degree, so the ends are opposite, then the left end is going to be going up. So it sounds like a lot, and if you kind of mentally tuned out and you're tuning back in, you're going to be like, wait, what? But you just look at the leading coefficient, sorry, see if it's positive or negative. Tells you what the right end's doing. Then you take a little peeky over here at the degree, see if it's even or odd, and that'll tell you whether the left end is going to do the same thing or the opposite. So looking here will tell you what the right end is doing. Looking here will tell you what the left end is doing. So yesterday when I was talking about the notes and I was telling you, oh, this is going to be an even or an odd, and I know the leading coefficient is plus or minus, that's what I was looking at. I was looking at end behavior. So I like to write it in simple terms first. This is the right end, it's going down. This is the left end, it is also going down. So think about what that means. So if you have a right end that's going down, think about what that means. Looking up at your notes, a right end that's going down means that you had negative coefficient. So I'm going to have a negative leading coefficient. Now the left end is also going down. I don't really care that it's going down. What I care about is that it's doing the same thing as the right. So look back up at your notes. If it's doing the same thing, that tells me that I have an even degree. So I can say same ends means that I have an even degree, which looks like one word, but it's not really one word. So as you go through here, it says, what is true about the degree and the leading coefficient? So I've already kind of thought it through. I've decided that my degree is even, so it's not this or this. And then I also have decided that my leading coefficient must be negative in order for the right side to fall. So I'm looking at my last two options saying I need my leading coefficient to be negative. So even degree, negative coefficient, D would be my choice. And we're kind of gearing up for that multiple choice semester finals. So that's an easy type of question to get asked. So now as you look through these, you want to be able to say, okay, what do I know? What do I know about my leading coefficient? What do I know about my degree? This is linear, but it still has ends. This is the right end and it's going up. So think about that. Right end going up. That's going to tell me that my leading coefficient is positive. The left end is going down, which is opposite. So if I look up here, an opposite ends tells me that my degree is odd. I don't have to know what it is yet. I just need to know if it's even or odd. So take a look through these. Right end up. Left end is also going up. So the right end going up tells me about my leading coefficient. The fact that they're doing the same thing tells me about my degree. Right end goes down. Left end here goes up. So I took a look at this. That tells me that my leading coefficient is going to be negative. Since they're doing the opposite of one another, this is odd. So try the next two, just kind of walk through them in your mind. Okay, so the right end's going up. My leading coefficient must be positive. The left end's doing the same thing. So my degree must be even. Here, right end down, left end also down. This tells me this about my leading coefficient. The fact that they're doing the same thing tells me that it's even. So that is kind of half the battle, knowing that it's going to go up, down. The writing it can be a little bit tricky. So I'm trying to find a space. Let's take a look at this one right here. Like I said before, obviously up is here, positive infinity. This is down, and that's going to be negative infinity. This is right, that's going to be positive infinity, left, negative infinity. So what you have to think about is when you're talking about the right end, it's going to be written in the fancy language as x approaches. So x is going this way because this is your x-axis. As x approaches positive infinity. That's what that language means. If you're discussing the left end, to get to the left, you'd have to go this direction on the x-axis. So you write it fancy like x approaching negative infinity, because that's what's happening. If you're going to the left, x is approaching negative infinity. If you're going to the right, x is approaching positive infinity. So when you're discussing the right end, use this notation. Or if they use that notation, just realize that's just fancy for talking about the right end. And this is what it will look like when they're talking about the left end. So then what we have to decide is that right end going up or down? So think about up and down. Up. Now, we used to call this y, the olden days, but now that we're really smart, we call it f of x. They're probably going to call it f of x as well. So if your graph or that end, the right end, left end are heading up, you'll see it written like this, or you'll have to write it like this. F of x, which is really just that secret fancy way of writing y, approaches infinity. Positive sign, optional. If your right or left end is going down and you're trying to describe that, then I would want you to write f of x approaches negative infinity. I'm absolutely ignoring this problem, by the way, and just talking about the notation. So say, for example, well, not even example, let's look at this one. Let's take a little peek at our first term. Our leading coefficient is negative. So the right end is going to go down on this graph. My degree is odd. So they're going to do the opposite of one another. So I can deduce that the left end is going to go up. Alrighty. The way you're going to be asked to write that or recognize it in fancy language to say this, it might read as, and now this is the right end, so I go up here, as x goes towards positive infinity, which is just saying right, y, which is fancy writing f of x, goes towards, and now since it's going down, negative infinity. So this is the notation that we're using to say the right end's going down. Why? Because that's called limit notation, and we're going to need to learn it in pre-calc so we can use it in calc. So we practice it in Algebra 2. So left end is going to be x going towards negative infinity. That's how you get to the left. And what's happening? Well, the graph is going up. So then f of x approaches positive infinity. So what I now know is that this is how I would write that fancy. And if you go back to the previous day's worksheet, that's how you do numbers 9, 10, and 11. So this is going to be on your worksheet, number 9, 10, and 11 on your day 1 worksheet, which we skipped, but now we have the information to go back and do. So according to what we just found out, since this is the right end, and we decided that's going down, we would have a y value of negative infinity here. Since this is the left end of our graph at x equals negative infinity, we saw that the left end was going up, so we would go ahead and have a positive infinity there. So we know what the ends are doing. We need some information about what's going on in between, so we might plug in some of these numbers. Now, in the interest of time, I'm going to assume you know how to plug in numbers. You can do it two ways. Plug them into your calculator. You're plugging them into this function. Or you can use that synthetic substitution that we learned yesterday. So for time's sake, I'm going to put these in here. Oops. I'll try using the correct numbers. This is what I got when I plugged these in. By the way, this is always going to be your y-intercept because it's what you got when you plugged in 0, because this would be nothing, plus nothing, plus nothing, and then a -3. So if I plot the points that I now have, -2, +1, 2, 3, -1, -1, 2, 3, 4. I'm just plotting those points. 0, -1, 2, 3. And then 1, 0. 2, 1, 2, -1. And then I'm supposed to draw a graph, keeping in mind that the left end goes up. So since this is the farthest to the left I have, it goes up from there. And then this point is the farthest to the right. And it doesn't go straight down. It kind of goes up, down, and over, up and over, because otherwise it would fail the vertical line test. And then I just do my best to connect it. So it comes down here, must come back up, must go back down. So this is my best guess of my polynomial graph without having to plot more points. I know for 100% fact my right end goes down, left end goes up. And these points. So, okay, let's try not a million more, because there are a million more. Let's try one more together. There are complete filled in notes online. So you can go to the filled in notes on Schoology if you feel like you need some more examples. Alrighty, I'm going to take a little look at this. And what I care about is this. My leading coefficient is a 1. So my leading coefficient is positive. Think about what that tells you. That tells me the right end goes in a positive direction. My degree is 4. That's my power, my highest power. 4 happens to be even today, which means my ends will do the same thing, which means my left will follow the right and go up. So if this is the right end going up, I'll need a positive infinity down here. If this is my left end where x is at negative infinity, then my left end is also going up, so this will be a plus infinity to end out that part of the graph. This is my constant. That's going to go below the 4 because I'd have nothing minus nothing minus nothing plus 4. So I know that at 0, 1, 2, 3, 4, I'm going to have a point. And then I'm just trying those x values kind of close in around 0. Plugging them in, you can either, again, plug them in using the substitution that we learned, the synthetic, or you can plug them in using your calculator, whatever you find easier. So when I plug in the -2, I get out a 12, and then so on across the board. Sorry, my voice is still terrible since September. Okay, I'm going to plot my points. -2, 12 is like super duper off my chart, so thanks, guys. -2 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up here somewhere. -1, 2, 0, 4, 1, 0, 2, -1, 2, 3, 4. And that's what I know. Like that looks like a bunch of random dots. So look at what you know. From the right, which is this last point, my graph has to go up. From the left, my graph is supposed to go up, so that's here. So I connect the dots the best that I can. And even though it's sort of imperfect, like I don't know for sure that that's exactly what it looks like, but I know for sure that this goes up, and I have to go through all these points that I got. And let's write this to practice. So the right end going up, I'm going to write as x goes to infinity, that's the right end, f of x goes to infinity, meaning up. Here, as x goes to negative infinity, so that's over here on my x-axis going to the left, f of x goes to positive infinity. So this is saying right end up, left end up. So now you should be able to use these notes to go back and finish the 5-2 day 1 worksheet, the parts we skipped, and then dive into the 5-2 day 2 worksheet, keeping in mind that tomorrow is Thursday and you have the entire class period to work. So you can ask me questions, you can come to academic seminar, but you're also super smarty pants and can help one another. So I'm not going to come back and reteach the lesson because you have this and you can utilize this to help you, but I'll be happy to answer specific questions. Looking forward to seeing you guys. Bye.